Hey guys, today we're going to talk about building a secure user authorization story. Now we all know that every application needs authentication. It's pretty hard to build an application today that doesn't need it. So the right question is not, do we need it? But the question is, how do we do it correctly? But first, let's talk about why it's important. In the first half of 2019 alone, 4.1 billion records were stolen. Now let's think about that. That equals 22.5 million records that were stolen every single day. Now, once there was a data breach, it takes on average 6 months to detect that breach. And once it is detected, it takes another 55 days to contain. So if you think about that, what this data tells us is that we need to stop thinking that we can build our infrastructure and build our application in such a way that it can't be hacked. And those practices are certainly good to follow, but we need to come to terms with and be okay with the fact that our data is going to get breached. Okay, and if we can put ourselves in that mindset that yes, our DevOps guys, our network guys, our security folks, they're going to do everything that they can to keep a breach from happening. But if as developers, we can take a step back and we can say, yes, it is going to happen at some point, then we can start doing things so that when that data is stolen, then passwords, for example, don't get put out there on the open web, right? We can make it so that especially passwords, if that data is stolen, it doesn't really matter. Okay, now we're not going to be talking about PII or HIPAA or FERPA or PCI compliance or anything like that. All right, we're going to strictly deal with passwords for the point of today's conversation. So the first thing I want to talk about, or mainly what I want to talk about today, is how to handle passwords. Okay, so the first thing that we're going to talk about is always encrypting passwords. Okay, we want to talk about policies that make sense. We want to ensure that we're working with password managers. We want to also ensure that we're using the proper user workflow. Okay, there is some thought that goes into what the user experience is, what the user flow is from login page to the forgot password page and things like that. So we want to talk about that for a minute. And lastly, we want to just talk very briefly about not using passwords at all. That's a fairly newish kind of trend. The idea's been out there for a little while, but it's really starting to pick up, I've noticed. So we want to talk about that for a minute as well. All right, so first, let's talk about always encrypting passwords. Now, technically speaking, encryption alone isn't enough. All right, it's not enough to just um, do something like an MD5 or some sort of simple cryptography encryption. What we want to do is make sure that we're actually hashing our passwords. Okay. Now, one thing to remember about good hashes versus encryption is even strong encryption methods can still be decrypted, right? But once you hash a string, it's a one-way hash. So you're not going to be able to simply reverse engineer that, right? You have to start getting into things like rainbow tables and things like that. You can't just reverse a hash. Okay. And again, simple hashes aren't good enough, right? We want to stay away from the MD5, and we don't want to just strictly take the user's password that they type in and then hash that. All right, so we'll talk about that. And to that end, we want to make sure that we use a salt. Okay, so if you don't know what a salt is, when we're talking about hashing, a salt is some sort of randomly generated string that you either prepend or append to the end of your base string that you're wanting to hash. Okay, um, so that might look like salt plus password or password plus salt. Now that salt is going to be unique to every single um, entry, right? So that's fine on your, we talk really quickly divert here and talk about your data storage. On your, you can put your salt and your hash, your password hash, you can put those together in the same database. That's okay. Um, and which you'll need to do because whenever the user tries to log in, you'll need a way to retrieve that salt, right? Otherwise, they'll never they'll never be authenticated if you are always randomly generating that salt every single time. So you use the salt, you create the salt, I'm sorry, when the user creates the password, and then you use the salt whenever the user is typing in their password in an attempt to log into your site. Okay, and then you can even go a step beyond salt and you can use a pepper. Okay, what pepper is very much like salt, except for pepper is something unique to your application. Okay, so instead of it being a per instance randomized string, it's a randomized string once when you create your application, you deploy it out there, and then every single user gets the same pepper, right? So pepper plus password. And then that way you don't have to store it in the database. You can store it in your web config, something that you're encrypting behind the scenes. You can store it in an Azure Data Vault or Key Vault or something, along those lines. So you can even put the two together, right? You can do salt plus password plus pepper, or pepper plus password plus salt, or pepper, salt, password, all kinds of different variations there, but you can use a salt and a pepper together. And what that's going to do for you is exponentially decrease the possibility of the user's password being in a rainbow table. Okay, because even if you're using SHA-2 or some really strong, good hash algorithm, if that password is on a rainbow table, it doesn't matter how good the hash is if that password has already been hashed using the same algorithm and exists in a lookup table or a rainbow table somewhere. So it's not gonna do you a lot of good. So that's where these salt and these peppers come into play. So now let's talk about some ways to use password policies that make sense. Okay, first off, allow spaces. I cannot think of very many create account pages where I'm allowed to create or use a space inside the password field. And that's always been confusing to me. I've never understood why I can't use a space. Um, it might have to do with our traditional way of thinking of a password as being a word, um, you know, but um, but really, there's no reason why a space would cause a problem. Um, so I would say allow spaces, right? The next thing, don't put an upper limit on the number of characters that I can enter. Okay, when I come to your site and I see that you're only allowing me, you're restricting me to say 13 characters or 20 characters or however many it is, even if it's an absurdly high amount, let's say 50 characters, what that tells me is that you're either encrypting, you're using a basic encryption, or you're storing my password in plain text. Okay, neither one of those feel good to me. All right, so um, let me use whatever number of characters I want. Okay, hash it, because that hash is then going to be the same size no matter how long the string is. It doesn't. You're no longer restricted in your data store by the amount of characters, right? By the size of my password. Um, so let's stop putting upper limits on the number of characters. And along those same lines, and this kind of goes back to allowing me to use spaces. Don't put a limit on what special characters I can use. Okay, it's very annoying to me when I go to a site and I open up my password manager and I say create a password, and it creates this really good password, right? But it can't be used. And it can't be used because I put a hashtag in the password, or the password manager did put a hashtag in there, and hashtag is not in the white list of characters for some reason. So take the time, all right? Allow me, it basically assume if I can type it, I can use it, right? Go with that mindset. Let me use whatever characters I want. And then on the back end, just make sure that you're escaping that input properly. Make sure you're sanitizing it properly, and then it's not going to cause you any problems. That's the only reason I can think that you would prevent somebody from using any certain character on the keyboard is you are afraid that that character will then break your input somehow. So let's not be lazy, folks. Let's escape our strings, and it's not much work. And then just let the users use whatever characters that they want. Another thing we want to make sure we're doing is not employing password expiration policies. This back in the day was something that everybody did, right? It was actually considered a good practice, right? The idea is that if you force your users to change their passwords every 3 months, 6 months, 1 year, however long, then what that does is it discourages the practice of password reuse, right? We all know that one password is the password should not be used another place. It's only good for it's best if only used in one place. So we said, well, we're going to force people to change their passwords, so that way if they're, I don't know, whatever, the password book gets stolen or something like that. But what studies have proven over and over again is that the policy of password expiration actually encourages bad password use. It increases my likelihood to use bad passwords. Well, why is that? Because as people, we aren't good at remembering complex strings. Okay? A good password is a complex string. We're not good at remembering those sort of things. So we come up with a good password that has to meet all of the rules that you put in place, right? We'll talk about that in a second. It has to meet all your character limits, your uppercase, your lowercase, no less than this many characters, no more than this many characters. It has to have this one or two or three of these list of special characters. So what do? We create a good password, we write it down, and then in 6 months, oh man, I got to change my password. Got to go through this whole rigmarole again. Blah, blah, blah. Okay, I'm going to do the exact same password within the number 1 after it, and then number 2, and then number 3, and number 4, right? So we go through this succession of having to. It's just the same password with a number that increments at the end. So then we got around that by saying, okay, your password can't be the same as your previous 10 passwords. Okay? Well, there's a workaround for that too, folks. When it's time for me to reset my password, you're going to force me to reset it every 6 months. It can't be the same as my last 10. So, random password 1, enter. And then I forgot my password. Right? New password. Forgot my password. Slam the keyboard. Then I forgot my password again. Slam the keyboard. Within 2 minutes later, I'm able to use my exact same password that I had before. Right? I just had to quote forget my password 10 times. So anyway, my point is, don't do things like password expiration policies. They are actually worse for your consumer than they are. But it sounds like a good idea, but it's actually not. So this we've talked about a little bit. Don't use seemingly arbitrary password rules. Your password can't be any less than 6 characters. It can't be any more than 25 characters. It has to have 2 uppercase letters, 1 lowercase letter, and it has to have one either a number or a special character. Right? I don't know who comes up with these things. We're trying to help people have good complex passwords, but what we've done is we've created a society of people who either have one password for everywhere they go, or they have a password book or sticky notes all on their monitors with their passwords written down. Okay, so we need to find better ways to determine what passwords we're going to allow or disallow in our system rather than these arbitrary sets of rules that we've come up with over the years. So, how do we determine which passwords we're going to allow or disallow in our system? Well, first, let's talk about what makes a so let's talk about now how we can determine what's a good way to determine what passwords we're going to allow or disallow in our system. First, let's switch away from this concept of changing or of setting passwords based on complexity. Or let me phrase that. Let's get away from the mindset of allowing passwords based on complexity. And let's start basing it on the time that it will take to crack. Complexity is only one part of the puzzle, right? But that doesn't help estimate the amount of time it will take to crack that password with any given hash or encryption method. Okay, so let's start basing it off that, and I'll show you a demo of what we can do with that, okay, in just a minute. The other thing we can do is we can take that password that the user enters and we can run it through Troy Hunt's API, which will help us determine if that password has ever been found in an existing breach. Is it on a known password list or is it in any known data breaches? And if yes, then we can simply not allow that password in our system. Okay, we don't want people using passwords that are on rainbow tables out there, passwords that are on people's master password lists. Okay, so let's talk about this first demo before I get into it. But there is there's a JavaScript library which I have linked down in the notes. But this library will help you determine how strong a given password is. Okay, so let me show you what that looks like. Okay, so here I have a password field which I've made really big so you all can hopefully see it well. And what this does, if I type in some word, like Bob, what this is going to tell me is that it only takes 2 microseconds to crack this password. It tells us some other things. We're not, for the purpose of this exercise, we're not talking about these other features of this library. We're focusing on the time to crack. Okay, so there's a password, some of the passwords that are on the there's some known password lists out there. So admin is one of those, and you can see that it's in the top 740 most used passwords. Okay, so what about admin 1, right? It's still in the top. It's still on those lists. Password 12, it's not on a list, but it's going to only take 8 seconds. I'm sorry, admin 12. It's only going to take 8 seconds to crack that, right? So we want to have passwords that are growing in complexity. As I type, you can see our time to crack has gone up now to 442,000 years. If I put a special character in here, it's going to take, this library estimates 1 billion years, right, to crack this password. I can just show you what it is here. I can't, and I don't remember what it is. Maybe it's something like admin space password, or and then the caret. But anyway, my point is, this is a good password, right? We can allow it in our system. So let's look at something with capital letters, right? So let's look at something that has to be 6 letters and contain uppercase and lowercase and a number. Okay, so here you go. I have met password complexity requirements on a lot of sites, and this password will only take 6 minutes to crack. And we'll try the same password over when we go over the Troy Hunt's demo to see if this password has ever been included in any breaches before. But my point in showing you this is that we are not good at creating password complexity requirements, right? 6 minutes is all it will take to crack this password, which does meet complexity requirements. Even if I put a special character at the end of it, so now it has an uppercase letter, it has lowercase letters, it has a special character, and it has numbers. And it will only take 1 day to crack. Okay, so, and it's more than six digits long, 6 characters long. It is 5, 6, 7, 8 characters long, and it's only going to take a day to pass. To crack. So my whole point in showing you that is we put these arbitrary rules out there, but even with those arbitrary rules, people still make bad password decisions. So now with that, let's move on to this other demo. This is a demo, and both of these demos, by the way, are done purely in JavaScript. Okay, there's no going back and forth, to the server or anything. With this one, there is. It's all done in JavaScript, but it's interfacing with Troy Hunt's API, and you'll see that it's pretty instantaneous. But what we're doing is, but what this API does is you take the password and you hash it. You create a hash, and then you send that hash, but not the full hash, only the first 5 or 6 characters or so. I can't remember exactly, but you send a portion of the hash to Troy's API, and then what the API does is it returns you back a list of all of the hashes and how many times those hashes have been found in his database. So if he has a hash that matches, you'll see it in the return. And then you can take the full hash and compare it and see when you find it. And then it'll tell you how many times that password is known. So let me go ahead and switch over to that. So here's Troy Hunt's API in the background. So let's start with those common bad passwords. Okay, so this password, this is the word admin. It has been used in breaches 48,000 times. It's been found. Okay, so let's look at that first one I showed with the other example of where the password meets complexity requirements, but is still a bad password. Okay, so we're going to submit that. That has been found 156 times. Okay, so let's now add the special character to the end. And that has been breached 26 times. Now again, this password meets complexity requirements by most websites out there today. It's more than 6 characters long. It has uppercase and lowercase. It's even stronger than their minimum requirements because it also has numbers and special characters. Okay, so let's put in what would be a really good password, right? We know, because we know that really good passwords are actually not words, but password phrases, right? Okay, so I just typed in a sentence here. And obviously, it hasn't been found in any breaches. So what I believe that we can do as an industry, instead of using arbitrary password requirements to determine whether a password is worthy or not worthy to be in our system, I believe we should take these two libraries, these two demos that I just showed you, and we can use the combination of the two to determine whether or not we're going to allow that password in our system. Has it ever been found in a breach? Yes or no? If no, then does it meet the length test? That library I showed you, by the way, how strong is my password? That library you can set. You notice it went from red to with one day to crack was red, but 20 billion years was green, right? Green was the accepted. You can change that length of time. You can make it 1 million years or whatever you want it to be that allowed time. But what's really cool about this is, if we did those two things, right? Is it on a bad password list? Has it been in a breach? And will it take a really long time to crack it if somebody does um, get a hold of the database, the data? And then we allow those in our system. And then on top of that, we pair it with a salt. And on top of that, we pair it with a pepper. Then we're putting ourselves in pretty good shape. Okay. Next thing I want to talk to you guys about is working with password managers. Because this is something, honestly, guys, I shouldn't even have to put this in here. Okay. And I get a little bit worked up talking about this because there are plenty of sites out there today that don't work with password managers. Okay? So let me just say this right up front. Always, always, always assume that password managers make better passwords than your users will. Okay? My password manager, which I use LastPass, by the way, and I'll link that in the notes below. It integrates in the browser, right? So I can trust that it will generate a password that is completely random, completely complex, is not used in any of my other passwords, right? So if my bank gets hacked and let's not use that. That's a bad example, right? We definitely don't want the bank to get hacked. If website X out there gets hacked and my password is found in that data set, and that password was stored in plain text, that doesn't affect me too much because I know that password was only used there, right? So you can't go to my bank and log in using that password because it is not valid at my bank, right? So the password manager helps them with that. LastPass even has a security challenge, which is really cool because it will look through all your passwords and tell you how many you have that are reused, and it'll help you change them. And with some sites, it integrates really well with, and you push a button, and it will actually go through the password reset process without you doing anything at all. It can automatically reset some of your passwords out there, and that is really slick, guys. It also works on my mobile device, right? On my cell phone, I have it installed, and I'm on Android. I don't know if iPhone will do the same, but it can take over the application, right? Uses the accessibility features of the phone, and it can put the password right into the apps just like it does in the web browsers for me. So it's really nice. So let's assume password managers, because this can't be said enough, let's assume that password managers will always make better passwords than your users will. So to that end, don't attempt to block paste, right? This is one of the ways in which some websites think they're being more secure. They don't allow you to paste in a password. Okay? Remember, some password managers don't take over the DOM. They don't work in the browser. Don't attempt to block the context menu, right? That's something you can easily do in JavaScript, is to block the right click from happening. But don't do that, guys, right? Just don't. Again, the purpose of doing that is you're trying to prevent me from pasting my password in. Don't do it, right? Let my password manager work, okay? Now, again, I said my password manager works in the DOM. So don't try to do things that block automated DOM manipulation. Don't try, right? Work. Last thing that I've seen some sites do is use obscure names for the password fields so that the password managers just don't recognize that the field is there. Again, I'm going to say don't do that, okay? Just create your text box, call it password, and be on your way, all right? Now I want to talk about, now that I've gotten off that soapbox, I want to talk about using the proper workflow. Because this is something that honestly doesn't get a lot of thought sometimes. And there are some actual really good reasons for making sure you think about this, about the flow of how this works. So let's start with a login page. Always put your login page behind a SSL cert. Okay? You'd be surprised at how many, maybe you wouldn't be surprised, but how many sites out there, when you go to the login page, it not only does it not default to HTTPS, but it doesn't work with HTTPS, which boggles my mind. I don't know how a site can be too cheap to afford an SSL on their login page, but they can afford an SSL everywhere else on their site, because what happens is you log in not encrypted, right? And then that takes you to HTTPS. There's a lot of sites out there that still do that. If you don't have SSL on your site, by the way, I strongly recommend that you get it. If you would like some help with that, you can reach out to me and I can help you. But SSL site certificates are cheap. They are very cheap. We'll say that. And depending on how you're set up, they can even be free. All right. Even if you're using Azure, if you're like an Azure Web Apps person, then your site can get a free SSL. Right. So if you're on Linux, obviously you can. You're hosting some sort of, like on Red Hat or something like that. So always make sure that you're using SSL. Now, one thing we see a lot of times on these login screens is it's indicated whether or not the username exists, right? So we say that username doesn't exist, or we say that password is wrong. And here's the problem with that, right? Sometimes, well, every time there's a data breach, the hacker says, okay, I now have 20,000, I have 20,000 users from your site, and I'm going to exploit you because I have that data, right? So I say, hey, CEO of widgetville.com, I hacked your data, your database, hacked into it, and I collected this list of 20,000 users that you have. I have a lot more data than that, but I'm only showing you this list of 20,000 users as evidence of proof that I actually did the hack. Now, I'm going to give you this list of 20,000 users in your system, and you're going to give me some money, right? You're going to give me $1 million, or I'm going to take all of this data that I've collected off your servers, and I'm going to put them on Pastebin, put them on Reddit, or I don't know, whatever, some site, right? Now, the CEO says, this is not good. This is really, really bad. Hey, Mr. DBA, take this list of 20,000 users and run it against our database and tell me, are they actually our users? DBA comes back and says, oh, Mr. CEO, yes, they are. So the CEO either coughs up the money or hires a consultant to come in and pays lots of money to figure out how the breach occurred, right? When all the user did was run a script on your login page with against a list of known email addresses to determine which of those email addresses were in your system simply by the username does not exist. Okay, so don't tell them, don't give them that information on that page, right? If you don't do this, then when they come to you and say, here's a list of 20,000 people I got out of your database, then you can be more confident that they actually got it out of your database and they didn't just figure it out or brute force it, okay? Again, work with password managers. I'm not going to say that enough times. Work with password managers. But we do want to say, lastly on this, if the nature of your application is sensitive data, then allow the option for multi-factor authentication. Okay, we all know what multi-factor authentication is, so I'm not going to get into that. It's not hard to do. It's not expensive to do. So if the nature of your application has sensitive data, then allow for multi-factor authentication. So let's talk about the forgot password page. Okay. Again, don't indicate that a username or an email doesn't exist. Okay. So this is that page. This is not the reset password page. This is the forgot password page. So let's not indicate that the username or password or email doesn't exist. And you might think that because it's uncommon, because it's not uncommon for people to have multiple email addresses, you might think, well, they just forgot their username, which you can give them a page for that too, by the way, or they forgot their email address. I myself have a lot of email addresses. And so if I come to this page, maybe I used a different email address and I just forgot which one I used. So rather than telling me in the browser that my email address doesn't exist, you simply say an email has been sent to the email provided. Okay. Now, you're always going to send an email, no matter what. Now, you're always going to send an email. And let's talk about that. Okay, because that email is going to have one of three possible workflows. Either the email address is not found in the system, and if this is the case, then you would just want to send an email explaining that someone used that email address to request a password reset. And you can say something along the lines of, if this wasn't you, you don't need to worry about it, all right? The email can suggest that a different email address was used to register, okay? And your marketing folks might want to use this email this as an opportunity to upsell the user, right? To invite them to create a new account. The next possible path is that the email address is found in the system. And I just realized earlier I said there were 3 possible paths. There's 2 possible paths. The second possible path here is that the email address is found in the system. So in that case, you just send them an email with a unique link that they can use to change their password. They just click it, and then it takes them to the password reset page where they type in their new password. Now, a couple things about that link. One, that link should expire after a predetermined amount of time. Okay, you don't want that link to be generated and then last forever. Okay. The second thing about that is that reset link should not bypass any multi-factor authentication that the user has enabled. Okay. Next, the link should be a one-time use. So the moment that I click it, or I'm sorry, let me rephrase that. The moment that I submit my new password, it should expire. And sometimes you see these even expire the first time that that page loads. And that's okay too. That's a little bit more strict. I think either one is okay. Either expire the moment I type in a new password and hit submit, or expire at the moment that it's clicked on, basically. And the last thing I want to point out here is that the user's password should not be reset until they type in a brand new password and click submit. Okay? Because what can happen is a user goes to the forgot password page, they type in their email address, they get the email, okay, they click the link, they go to it, and as soon as they start creating a new password, then they remember what their old password was. And then so they can just go back and log in. Okay. So don't actually disable the account or reset the password just because that forgot password link was clicked or passed out. Okay. So lastly today, I want to talk about going passwordless. So there's a few options here. One thing I heard a long time ago from someone is on a podcast. I don't remember which one, but I heard somebody make the comment, don't do passwords at all. Just let someone else do it for you, right? Let the Microsofts, there's Microsoft login, Facebook, Google, Twitter, LinkedIn. There's plenty of third-party services that somebody pretty much is guaranteed to have an account with that has a social login aspect to it. So a lot of people are on that camp. Just let someone else handle passwords for you, and that's okay. I don't really trust those social media providers and their APIs. I'm not a big fan of them myself. So um, so I like to handle the passwords myself. However, having said that, there's still some other things you can do to go passwordless. Basically, you can use that multi-factor authentication method that the user had enabled. You can basically shift that over, right? And just use that as the password process. Okay, so there's authenticator apps, there's the magic link method. Let me just talk about those for a second. So magic link is, very similar to that I forgot my password page, right? You go to the site, you type in your email address, you click login, it emails you either a magic link or a code, and then you either click the link or you type the code, and then you're in. The next time you want to log in, you do the same thing again, right? So there are actually no passwords stored in the system. So that's one way to do that. The other way to do that is using an authenticator app. Okay, so Microsoft has one, Facebook has one, Google has one, LastPass has one. So there's plenty of different authenticator apps out there that you can use, and so I type in my email address, I click submit, and then it says give me the code from your authenticator app, or it says you get a push notification on the phone, right? And you have to approve the login. So there's a couple different ways to do that. But again, it's basically shifting the multi-factor authentication. It's shifting that to the front. and using that as the password. Okay, so I've hoped you have enjoyed this talk today about how to properly do a user authentication story or user authorization story. And if you like it, thumbs up the video. If you hated it, thumbs down the video. I'm fine with that too. And leave me some comments. Let me know what you think. Let me know what you do, how you handle user authentication. Do you do anything differently? Do you agree or disagree with anything I said, and why? I'm very curious and eager to know what you guys are doing out there. I will talk to you guys next time, and take care.